So you see, in this problem, we have to find tension T in the belt on the pulley beam and X, Y, and Z components of reaction and general bearing C and at general bearing T. If you notice, you are also given an angle which has a value of 45 degrees. So at the bearing C, we have two reaction forces acting, and at the bearing D, we have three reaction forces acting. And you see that this is the free body diagram of this system. You see, we can find this tension if we apply moment about x-axis. So we get 65 Newton force, which has a perpendicular distance of 0.08 meters. And you see it is moving in anti-clockwise direction. And also we have the 80 Newton force on the other side of belt, which has a perpendicular distance of 0.08 meters. But you see it is moving in the clockwise direction, so it is negative. And on the other pulley, we had a tension T on one side of belt, which has a perpendicular distance of 0.15 meters. And on the other side of belt, I have also a 50 Newton force, which has a perpendicular distance of also 0.15 meters, but it is negative because it is moving in the clockwise direction, but this tension force is moving in anti-clockwise direction. So through this, I get the tension in the belt, which is about 58 newtons. Now, if we apply the moment about y-axis, so we can find the reaction force in the z direction at the bearing C. You see, we have a collective force of 65 plus 80 newtons, which has a perpendicular distance of 0.45 meters from the y-axis. And in case of this 50 Newton force, you see it is moving in the clockwise direction, it is negative, and we can use the sine component. And you see that it has a perpendicular distance of 0.2 meters. And in case of the CZ, which is the reaction force, we have a perpendicular distance of 0.75 meters. And it is also moving in clockwise direction, so it is negative. So we get the reaction force at a bearing C in the Z direction, which is about 77.6 Newton. And you see, we can also apply movement about the Z axis. So we get the reaction force at the bearing C in the Y direction. See, we have the 58 Newton force, which is the tension force. And we have a perpendicular distance of 0.2 meters. Last, we have this 50 Newton force because you see it is moving in with the y-axis, so it is also moving with the z-axis. So we use the cos component, and it also has a perpendicular distance of 0.2 meters, and we have the cy force, which has a perpendicular distance of 0.75 meters, and you see it is moving in the clockwise direction with respect to the z-axis. So we get the reaction force at Y at the bearing C in the Y direction, which is 24.9 newtons. And in case of the horizontal forces, which is the force in the X direction, we only obtain the reaction force at the bearing in the X direction, which is 0, because you see we have no other force that is acting in the X axis. And in case of the force in the vertical direction, we have the dy force, which is the reaction force. And we have the 24.89 Newton force, which is the cy force. Thus, we have the 50, which was 45-degree force, and we have also the tension force. So we get the reaction force at bearing T in the y direction, which is 68.5 newtons. And in case of the forces in the z direction, we have the negative C force, which is also a reaction force at bearing D. And we have the 65 Newton force and also 80 Newton force, which are acting in a negative Z direction. And we have the positive 77.57 Newton force, which is the CZ force. And we have the 15 Newton force, which is also moving in the Z direction. So which has a, so we use the sine component. So we get the reaction force in the Z direction bearing T, which is about 32.1 Newton.